All right, welcome everybody to this month's Ceph Tech Talk. This month we have Chris Holcombe from Canonical who's joining us to talk about a couple of different topics. It sounds like he'll be touching on some tricks to deploying Ceph at scale, probably looking at their Juju stuff, but I'll let him expound on that, as well as writing an application with the language bindings. So there are a number of language bindings, as you may or may not be aware, everything from Python and PHP to R and Go. So definitely interested to see what he has to say in terms of examples of what they're doing. So I will let Chris take it from here.
Hey everyone, morning, afternoon, or evening, depending on where you're at. My name is Chris Holcombe. I'm the senior storage lead over at Canonical. And today I'm going to talk about deploying Ceph at scale. We have a number of customers that have deployed our stuff in the low to mid petabyte range. And that's helped bring back some feedback and help us help us get our tools to the point where it makes it easier for everybody to deploy Ceph, because Ceph can be, if you've looked through the wiki, it can be a little bit challenging. So let me share my screen and show you guys what I'm talking about. So if everybody can see this, I've taken my screen and split it up into 3 panels. On the right here, this will be our panel for running commands. On the left here, this is my window into EC2. And we're going to make an attempt today to run up a large Amazon bill. On the bottom here, this will be my debug logs. So let's clear the screen. So the way we've been deploying Ceph at Canonical is we use what's called a charm. And a charm is a set of hooks that allows you to make your application plug in or communicate easily with other applications. And I'll show you what that means. So let me deploy the cephmon cluster. So we're going to do a Juju deploy, cephmon, and I have it pulled down locally. So we'll do N3 because we want to have a quorum. And the config we're going to have is a little YAML file. I'll show you that YAML file over here. Basically, for cephmon, there's no options I have to give except I'm telling it where to pull the cephmon binaries from, or the Ceph binaries from. And we have something called Cloud Archives that allows you to have quick updates on Ubuntu. So I'm going to say 3 of those. And I'm going to deploy it on Trusty. Let it go. You can see now on the left here, EC2 is giving me 3 machines, and they're going to start coming up in a minute, although sometimes EC2 can take a while. And as they come up, they're going to communicate with one another and they're going to go through all the basic commands that you would go through when you put together a monitor cluster. And expanding it is actually really easy. You can do Juju add unit, cephmon, and then n, and the number of units you want to add. And as you add units, it will automatically expand the cluster for you. So this is not all that interesting without OSDs. So let's add a bunch of OSDs to this as well. And I don't know, maybe we'll add 6. I'll show you the YAML file again for the OSD. Using the same source here. I'm unmounting the ephemeral mount, and I'm telling it to use the XVDB OSD device. And all the EC2 machines come with this. So they come with like a little EBS block storage that's mounted at /mount. So I'll just use that. You can see here once the machines actually get going, they'll start spitting out tons and tons of debug log information. Let me kick that off. Actually, these charms have a lot of config options to them. I'll show you some of them while this is deploying. That's a little hard to read. So you can separate out OSD devices, the journal, what size of the journal you want, what format. You can do different formats, XFS, 64, Btrfs. You could turn on encryption by default, and that uses dmcrypt. We can give it a different source. So if you have your own packaging of DEBs, you could tell it to use your PPA, you could tell it to use the cloud archives, or you could stick with the default. You can also tell it to split up the public and private network, use IPv6. You can customize the failure domain. There's many, many options at this point. And something I recently added, which is neat, is called auto tune. And after Ceph starts up, it will look at all the OSD devices and try to make its best guess about read-ahead settings and the elevator to use for the hard drive, etc. And also, like if it sees you have a 10 gig network versus the default on EC2, which is 1 gig-ish, it will try to do your ccTL settings as well to modify that and make it more efficient. So the idea is that everybody gets a fast Ceph cluster out of the box. So normally, this takes about 5 minutes or so to start up, depending on how long it takes for EC2 to give us machines and how long it takes for Python to install its dependencies. So the interesting thing about this is these charms, I'm using the EC2 provider right now. The idea is to make it easy to, or make it identical to deploy this on Metal or a VM like we're doing now, or container. So you might want to have your Ceph mons in a container versus a VM or maybe even hardware. And using the MAS provider or the Google Cloud provider or the LXD provider for containers, these charms act identical on all those different substrates. You can see now they're giving you some information about I'm ready to bootstrap my cluster, but I don't have enough other units there. The default is try and keep everybody safe. I default to needing 3 mons instead of just one. That way, if you have 1 or 2 mons that go down, you still have a working Ceph cluster. Without the monitor cluster, Ceph would fall over. So I didn't say this before, but if you guys have any questions, feel free to stop me as I'm going through this. I know when I first started at Canonical, the whole idea about charms and what they were doing seemed very magical and weird, and there was a whole lot of jargon around that I had trouble getting around.
It might be helpful to just tell the elevator pitch for Juju for those that aren't familiar with it. I don't know that a lot of people realize that it's a alternative to other orchestration and deployment frameworks like Ansible or Ceph or Puppet or whatever.
Sure.
What makes it different?
Yeah, the elevator pitch for Juju is you're trying to create an application model and make that easy to plug into other applications. So the Juju charms, they export what's called an interface. I'll show you what that looks like here. It says my interface here is Ceph, and if any other charm supports the Ceph interface, they'll be able to talk with one another and set themselves up. So if I have a client like for here, I have the Ceph client interface. I have the Ceph admin interface. If I want to hook up, say, Rados Gateway, or I want to connect OpenStack or something like that, I can relate it. And see, you'll see this right here. I'm missing my monitor. I'm not related. To do that, you do juju add relation, cephmon, cephosd. And now they can communicate with one another. And that'll finish setting up the Ceph cluster. So the idea, I guess, is to give your application a little bit of additional intelligence, and that'll allow it to plug into all kinds of other things in the ecosystem. So I'm going to jump onto one of these nodes and show you. We can see that cluster came up. I have a few default pools, and OSDs are getting added slowly but surely. You can see here that the disks are getting scanned, XFS is getting put down onto them, journals are getting set up. All of that is happening through the Ceph deploy tool, or Ceph disk prepare rather. There we go. So in another minute or so, we'll have a working Ceph cluster with 6 OSDs. Yep, there we go. Yep, it takes Ceph a minute to distribute the placement groups around. Maybe we'll put a little watch on that.
Chris, we had a question coming in on chat here asking about does the charm handle multiple OSDs in a server, and specifically different types of OSDs like SATA versus SSD that you might want to add in?
Yeah. That's a great question. It does. So the default is, not anything like EZ2. You'll probably have 24 or 30, or for the open compute systems, maybe even like 45 or 60 OSDs on a server. It'll handle that. And there's 2 ways you can go about it. The first is the cheating way that I did, which is I say my OSD devices are this space-separated list. The other way, so you can give it a space-separated list of OSD devices. The other way is you can say juju deploy Ceph OSD, and then you could say dash storage OSD devices equals, let's say, I don't know, 1 terabyte, and you want 30 of them, something like that. And depending on the provider, being either MAS or EC2 or Google, it will pull that from different. It will find those drives from different pools. So for the MAS provider, which stands for Metal as a Service, it will look for a tag. So you can either tag your drives as SSD or slow or fast or something like that. It will handle finding the right drives and adding them to. It says you want to add them to different crush routes. Oh yes, it supports that as well. It's a little bit more complicated to set up. Let's see if our cluster is all set up at this point, because I know before it was saying that the placement groups were stuck. The joy of live, the joy of live deployments. So what I wanted to show you was the Ceph version that comes with Trusty by default is really old. 8011, I think, is Firefly. So what I wrote recently to get around that was an automated upgrade, an automated set of upgrade steps. And you guys know from running a Ceph cluster, the way you upgrade your Ceph cluster is first you upgrade your Ceph mod cluster, you log into each one, add your new packages, and then restart one by one so that you maintain your quorum, kind of roll through it. And then you go through your OSDs one by one, same exact procedure. So all I did was I automated that. I could do config, I think it's source, and I'm going to have to look this up. So I don't remember it exactly. So after Juno, for the Cloud Archives follow the OpenStack release schedule. So we have Juno and then Kilo. I'm going to say for Ceph Mon, the Kilo. Now what happens here is the charms are actually leveraging the key value store that the Ceph Mon cluster has, and it's taking advantage of that. So they're setting keys on the monitor cluster, and I know this debug log is extremely noisy. Just ignore that for the moment. They sort themselves by IP address, and whoever has the lowest IP address goes first, and the other two say, I'm waiting on him. They set a key, or the one who's starting sets a key on the monitor cluster saying, I'm upgrading myself, and the other two see that as a lock, and they wait on it. So the noise you're seeing from the upgrade log is all the other two monitors saying, I'm trying to find this key, saying that the person before me or the monitor before me is not done yet, but it's not there yet. So they wait. I think the default is like 20 minutes or 15 minutes. And if that doesn't happen, they'll assume that the one before them is dead and keep going. The reason for that is we've noticed that at scale, when we run this, that failures happen, and it's not all that uncommon. So maybe you have a machine that's kind of wonky, or maybe it crashed in the middle of an upgrade, and you don't want your whole cluster to stop upgrading because of that. Third monitor is still waiting on him. Yep, and they flip back to saying, I'm ready, I'm clustered. So we can actually do the same thing with the Ceph OSD cluster once the monitors are done. And I haven't written any code yet to prevent you from shooting yourself in the foot and upgrading OSDs first and then Mon second. I can come a little bit later. It was kind of like, let's get it going first, make sure it works, work out the kinks, and then from there we can go, into more advanced functionality, which is let's make sure you upgrade in the right order. Don't upgrade your Rados gateway first, your OSDs first, etc. So this usually takes like a few minutes. We can log into cephmon 32 just to make sure that everything went okay. You can see now 94, I believe, is Hammer. So my placement groups are still stuck. I think I know why that is. There's a bug in a very old version of the charm, or in Firefly, that the charm hasn't worked out. I can fix that later, but it's not worth fixing right now, live. So we're on Hammer. Second monitor's done. Third one's upgrading itself. And that's about it for rolling upgrades. Is there any questions about rolling upgrades? Does that make sense? Looks like everybody's happy with that.
Straightforward, yep.
Yeah, I felt like Ceph has a rolling release, and for some of the bigger clusters, I always have to think about, should I script it? How can I get around logging into like 200 machines and doing this? So the other part of my talk that I wanted to talk about was FFI bindings that I've created for Ceph, and I've done it with my friend Chris Jones, who's actually on the talk right now. Thanks, Chris, for joining. So let's see. I will try and do everything in front of you so that doesn't look like I'm cheating or anything. What we're going to try and do is, I think, create a really tiny application that connects to our Ceph Mon cluster and prints out the current usage of the cluster. And I wanted to send that over to InfluxDB, but I'm not sure I can get that done in like 30 minutes. So maybe we'll just stick with printing it out to standard out. So the cool thing about these FFI bindings that Chris and I made is that they're written in Rust. And Rust is a memory-safe systems language. And it takes the idea of RAII, which is resource acquisition is initialization, and actually bakes it into the compiler. So you'll see in a moment what that means. You can fearlessly code multi-threaded applications, allocate memory on the heap, on the stack, and there's no worry about memory leaks or bugs of that sort of nature. I'll show you what I mean. So that's that over to my read. Oops, and I'll make a new project. Ceph usage. Oops. So here we go. Monitor Ceph usage. The way Rust works is it has a TOML file, and it says who the author is, the version, and any dependencies. And these dependencies can be pulled down from crates.io really easily. I happen to have the Ceph Rust bindings already on my machine, so I'm going to say Ceph Rust is in this path, which is right behind the path that I'm in right now. So I'll close that, and I'm going to go over to my IDE Atom, which makes it a little bit easier to code with, and I'll show you some different aspects about F5 bindings that Chris and I made. Let me switch my screen here. We'll add our project. Let me introduce you to Ceph Rust here. Oops, look that pretty. These are a safe wrapper around librados, and we can do some interesting things with these. Right now we're going to just write a little hello world application, but since we have safe bindings to the underlying C library, we could actually write new clients for Ceph. So maybe you could write a Ceph archiver that would sit, next to CephFS and Rados Gateway, and it would be as fast as the C or C++, the C++ that Ceph's written in, but also not have a garbage collector overhead like Java. So Rust is kind of in this interesting space. One of the things that I've written with it is called, I made some extensions to this project called Preserve, and it takes a directory or a set of directories that you give it and encrypts them and then sends them into Ceph, into Rados. So it breaks them into chunks and encrypts each chunk and sends it into Rados. So That was pretty cool. It's fast. Been very useful, actually. And we have a large client who's using it. The Ceph Rust library consists of two pieces. The first one is the Rados.rs module, and that is the low-level bindings to Ceph. So if there's anything that I haven't written a safe wrapper around, these were the bindings that you use. And with Rust, anything that's calling down to C is considered unsafe. That's because Rust can't track memory usage inside of C. It tracks lifetimes and a bunch of other things. And so what the deal is everybody who's writing Rust who wants to interface with a C library, they will write a safe wrapper around that. Like for instance, this, where I say I'm going to connect to Ceph. All these C operations are unsafe, and I'm telling the compiler that what I'm doing here, the compiler is saying, I don't know what you're doing, but I'm gonna leave it to you to make sure you don't do anything that's bad. So with Rust code, everything outside of that block is safe, and you can be sure that you're not going to leak any memory. And if you do end up leaking memory, it's almost assured that it's going to be inside these unsafe blocks. And I actually had a few bugs that have cropped up in the library as I've been using it, and they're always in these spots. So you've reduced your surface area of memory leaks to this small portion of where these unsafe spots are. And it's easy to figure out where they are too, because they're wrapped. Anyway, let's go back to our application here. And we're gonna import our crate. Ceph Rust. We're going to try and connect the Ceph. We're going to print out the usage, and then we're going to exit. And we could either do that in a loop, or we could probably add a timer to that. Let me check back on the box, see if there's any questions. No, looks like everybody's following along. Okay. We're going to say we're the admin user, and we're going to say that configuration file sits there, and all of my functions, or all of our functions in the Ceph Rust library, they return a result, which gives you back the actual thing that you want, which is this Rados T handle. And if you've worked with Rados or librados before, you'll know that from my understanding, Rados T is kind of an initialized block of memory that Ceph references to know that you're a connected client. Excuse me. So the cheating way to handle this in Rust is to say unwrap. And what unwrap means is if I fail, panic and quit the application. But if I don't fail, give me the okay result. So normally, if you were writing a robust application, you wouldn't want to use unwrap, and I really discourage using it. But since we're kind of pressed for time here, I'm going to say everything's going to go okay and it's going to be fine. So let's go back to our library here, and let's get the usage. So we've got a function here, safe wrapper. It's stat the cluster. You give it back. You hand it the Rados T and it will give you the total space, the space used, the space available, and the number of objects. So if we're logging that to like Prometheus or InfluxDB, this could be really useful, so you can see the usage change over time. And also, if you're logging the number of objects, you could probably divide that into the space available to get your average object size. So that could also be interesting if you want to know, are the clients who are writing to my cluster writing large objects, small objects, medium-sized objects? And if they are running small objects, which is really inefficient with any kind of distributed storage, why are they doing that? Maybe I can help them fix whatever client or program they're using that's writing into it. So let's grab this. So I'll say, oops. Let the cluster stat equal this guy, and he takes a cluster connection. Again, we're going to say unwrap, because we're cheating. And we're going to print this out. Cluster stats. 3 lines. Maybe we do have time to log it to Influx. So let me switch my window here because compiling is not going to show up in Atom. Let me switch back. So Rust recently, as of 1.16, has this new feature called check. And instead of building a binary, it downloads everything, does the statically compiled checks, but doesn't build a binary. So it's quite a bit faster. So you can see, whoops, I messed up a couple things here. Rust actually has some really good error messages. It will actually underline and tell you what's wrong and try to give you a good note. And it actually, a lot of times, it even solves it for you. So it'll say something like, I noticed that you can't format this thing that you're trying to print out. Did you try using this instead? And that actually is the answer. So it's really good about that. So let's go back and fix that. So I'll say, instead of this, I'm going to do that. And that should take care of everything. So now we should be able to drop this over to our Ceph cluster, get the current cluster status, and quit. So sorry for bouncing around here. Let's do a hardware check again. It says everything's good. So now we'll build it. Run through and do everything again, but actually build a binary. Now we have our binary in, it puts it in a directory called target debug. You'll see this new binary, monitor Ceph usage. Let's send it over to our Ceph-mon cluster and see how it works. Monitor Ceph usage, we'll send it to Ceph-mon 30. And supposing I didn't mess up anything, this should work. There we go. We have, looks like 200 megs that we've used, and we have no objects in the cluster, which is correct. That jives with what CephDF is using. Roughly 200 megs and no objects. The question? Thank you. Rust is a beautiful language. Yeah, I really enjoy writing in it. Should we try and take it further and maybe log it to InfluxDB? I don't know. I could start up an InfluxDB on Juju really easily. What do people think about that?
Looks like we have a vote for yes.
Chris says go for it. All right. So, B. Let me me go find the chart name. I think it's actually called something different. Oh, that's right. Okay, so it's under my coworker Chris's. It's under his charm store name. So we'll deploy that. That's going to take a minute to start up. So while we're doing that, let's head over to the crates.io where all the libraries for Rust are being posted to, and we'll find the Influx library that goes along with this. Let me stop sharing that. I'll share my Firefox. Or maybe I could just share this screen. That's fine. So we want an Influx library. Let's see, we have a client. HTTP client, that looks fine. Yeah, I think write one is good. So we need to create a new client with some credentials. We'll write one and then we'll quit. All right. Let's go back to Adam. And this thing was called Influent. So Influent equals, and you can, I'm taking the lazy approach right here of just saying, I don't care what version it is, just get the latest. But if you want to pin it down, you can say 0.20, like an exact version, or you can say an approximate version. Anything that's 0.2.x, something like that. That's what this tilde means, I believe. So all the crates on crates.io, they use semver, semantic versioning. So anything in 0.2, 2 or 3 or 4 should all be compatible with one another, but 0.3 won't be compatible with 0.2, generally, if everybody's following the rules. And you can see Cargo actually makes my semver when I start 0.1. So all I have to do to pull that in is do a cargo check. And it'll download it from crates.io. It'll compile it and check that everything works right. While that's doing that, just gonna create Influent. And I need to import the right module here. It is the client, HTTP client. Now we're going to get slightly fancy and say, instead of just printing it out, we're going to looks like it takes credentials, a serializer, and a hurl. I'm not sure what that is. Like a username, password, and database. That's a great question. I actually don't remember what the defaults are. I'm looking. The reason I don't remember is because, the Juju charms actually, when they're related to one another, they pass this information back and forth, and you tend to forget about all the little details about what's going on. Database names, usernames, passwords, etc. So let me see if I can look that up real quick. And it looks like our InfluxDB is almost finished. It says it's installing. It's on port 8086, it looks like. So I can fill that in. Let me switch my screen again. So name, password, paste. Oops. And feel free to interrupt me if you guys have questions. I actually didn't plan on doing Influx, so that's why I'm tripping over various things. Let me try to find this password. Oh, it's root. Duh. All right, and the default database name is. We'll find that in a second. So root. Hang on one sec. I have another library that uses this. I can cheat just a little bit. Password equal same thing. It is Ceph. Actually, we don't even know this. We're needlessly complicating things. Influx hosts. What is our influx host? It looks to be this public port. That's actually a good point. I forgot to say. By default, the charms that you deploy are they're firewalled off from the world. And what you can do to get around that is you can say Juju expose, and it will open up that port and allow anybody to connect to it. So if I say Juju expose InfluxDB, now anybody that connects to, and I'll give you the link in a second. If you guys connect to this, you should see, I think 8086 or 8083, you should see an InfluxDB there. Yep, 8083. We're at 8086 for port. There's one piece missing from this, which is create client. I think that should do it. Credentials, hosts. Actually, it looks like I don't need this. Yeah, and then down the bottom here, we got our measurements. So we're going to say this is a usage measurement. Storage type is Ceph. So it would be really nice to know if we had multiple Ceph clusters, which FSID this particular measurement is coming from. So we need a timestamp too. So let's go up. Need to use time. The create is external create time. Or I could be wrong about that. Nope, that's right there. We will drop that into our cargo.toml. I need time. So maybe we should ask our F5 bindings for the FSID as well. And I think that's in there. Let's see. FSID. Yep. We'll say let the FSID. Oops. Sorry, I'm using Vim bindings here. We'll equal that call. We'll pass it in cluster connection. And we'll say everything's going to work fine. It's never going to error. And we'll unwrap it. We'll connect to our InfluxDB at port 8086. At that IP address, we're going to say the database is Ceph. There's our host. Here's our client. Create our measurements. This. We're going to fill in our FSID. Hopefully that will compile. What do I want? Oops. That's it. Add a field. Usage is cluster stats dot see what I printed out here. KB used. Oops. That is num objects. And we're going to need a total as well. And I believe that's just KB. Sorry, my kid is upset out there. I have a little 3-year-old. So I think we have everything. Let me try and compile that, see if it works. And if it does, we can send that over to Ceph, and we'll record some stuff on InfluxDB, and everybody will be able to see it. So cross your fingers. We'll know in a second. So let me cargo check that. And it looks like I forgot to import a couple things. So I forgot to import measurement. Oops. And value. Let's take care of that. And looks like FSID needs to be a reference to a string, not actually a string. Oops. I need to say oh. So Rust has the concept of lifetimes, and it's saying that if you just create a reference to a string inside this function, it will destroy it before the function ends, and this field here doesn't live long enough, so you need to actually move it up in the call stack. So that compiles. So let me do a cargo build. That's going to take a second, and I'll switch windows and see. So let me see if there's anything else I have to. Oh, yeah, I got to write it. So we're going to write our measurement. We're going to say our precision is seconds. So we're going to print it out, and then we're going to write it to Influx. Let's see what happens. I need to use Influx client. And it's also some missing precision. Where is that? Okay. Okay, that built. So let me see what screen I'm sharing here. Switch over to my terminal. So our Ceph usage has gotten quite a bit bigger. It's almost double the size as it was before. Let's SCP it over to cephmon 30 again. Whoops. Cephmon 30. Right. And let's cross our fingers that all the unwraps I did are going to work. It didn't fail. Is anybody seeing stats over there on InfluxDB? Let's see. My terminal. Oh, I know what happened. I think I didn't create the Ceph database in Influx. Dang it. Well, I think that's all we have time for at the moment.
Anybody have any other questions for Chris before we wrap it up here?
Yeah, sorry, it's kind of a whirlwind. I went pretty quick. I didn't explain a lot of things.
I think it was good. It gave us a good overview of all the pieces. Looks like most people followed along pretty well, though. So thank you very much, Chris, and thank you everybody for coming. We will see you again in April. I believe the next one is on the 27th. Yep. Same bat time, same bat channel. And in the meantime, we'll see you on IRC and the lists. Thanks, everybody.